Next, we are going to measure our losses, right? So how do we do that? We take the predictions, subtract them from the original price, square it up. So this is basically tf.pow. Pow is a power function, and writing a comma 2 there means do the squared. So if I write 3 here, it will cube it. If I write 4 here, it will make it to the power 4 and so on. Okay, so we want to measure the squared errors in this case. So we will write 2. And then finally, we'll sum each of those errors up and then divide it by the total number of observations. So here non-trained samples is the total number of observations that we have, which will give us a representative or an average value of the loss that we were going to do. Okay, so the loss is also done. So we've prepared our data, we've drawn the inference, we've built this computation graph, we have written code to measure errors. Finally, we are going to optimize. So this is where the real magic happens. I'm going to set the learning rate to 0.1. So this learning rate is the rate at which you want to learn. Ideally, you don't want to set it to a very low value. Otherwise, it just takes forever. And you don't want to set it to a very high value. In that case, it does not work very well. It does not converge to the optimal solution. So in this case, what we are going to do is set it to a modest rate of 0.1. Then we're going to use, as I said, the gradient descent optimizer. So again, with TensorFlow, it's just available to you. Okay, so we're going to invoke TensorFlow.train.gradient descent optimizer. The gradient descent optimizer needs to know the learning rate. And then we are going to minimize the cost function, right? So the cost is basically the loss, the thing that we computed over here, the squared errors. So our optimizer is going to minimize the cost. So just going to execute these two snippets right now. Done.